All right, so when we are finding the average value, this is what we do. And there are pretty simple steps. This is what we do. It says that steps number 1 to 4, it says you identify the cycle, right? So we know that there's the waveform, but there's a cycle, meaning it starts somewhere, ends somewhere, and then repeats that same cycle again, right? And then we find the period, right? The period is the time it takes for it to complete that cycle, right? This right here is time. Let me bring this here, time. And then the next thing it says is that you find the area under the curve, right? The area under the curve. When you find the area under the curve, you finally then you divide that area by the period that you found earlier. Okay, so you are going to use this simple example to get a basics. So this was it. So we are trying to identify the cycle. Now we are here. We are here, right? So the cycle. So if it starts from here, right? So it starts, goes down, it moves this way, and then up. Right. So this is one cycle. Why? Because you see, it started by using a horizontal, right? So if it started here and moves down, goes here, ends here at this side here, mean that if it wants to start another cycle again, right, it will just have to start here and then go this way, right? So this one cycle. So we can see clearly, we can see clearly that this is one cycle. So that's one cycle. Oh, sometimes missing. So we have some 2, 4. We have a 6, and then wherever this one ends with something, we have a 8, right? So we've identified one cycle without this. Step by step, one cycle. The next thing to say is that find the period under the cycle, right? We've identified one cycle. We are supposed to find the area. A minute, we missed something. So basically, we talked about the amplitude, right? We said peak. So when here you don't hear amplitude and you see peak, they are the same. So basically, we have this in here, right? Positive value. But then because it's freehand, you see this the portions here, the lengths here are not the same, but it's a freehand drawing, so they are the same. I'm just saying it here. So if there's positive, there's negative, right? These are the peaks: positive peak, negative peak. So now it says find the period of the cycle. So we know our cycle starts from here, this, and then the time is on this scale, right? So now we know where it is. For us to be able to find our period, this is what we do. So the cycle ends here, so 2, 4, that gives us 4 seconds, right? So clearly we can see that our cycle is 4 seconds, right? Then it says find the area under the curve. Here, here's what happens. If it's a negative area, we see. If it's a positive area, we see it. We don't leave any negative out, right? If you leave anything out, it becomes something completely different. Okay, so this is how. So when we find the area, then we divide the area by the period. So these are the formulas. We'll talk about the integration later. We'll talk about this. Just the same thing. Instead of going through the stress of getting the formula, we don't know the formula, can do integration. But let's see. So now we know our cycle, we know our period. The next thing is we have to find the area under our cycle, right? So you clearly see that if we are talking about areas, right, there's one thing that we must consider. You must be able to see the cycle clearly. If you don't see that, we won't be able to find the area under it, right? So now we're just going to clean this up and find the area of interest. The area, minute. Okay. Okay, so now it's cleaned up. So looking at this, you can clearly see that if our cycle start here, and we've seen that already. Minute. If our cycle starts here and ends here, we can talk about two areas, right? One area will be here, right? Because of this E here, it will end up being a positive area, and this one right here will end up being a negative area because of this negative E here. So now let's see. Area of a rectangle is length and breadth, right? So this will be our length, right? And our breadth will be, sorry. This will be our length, this will be our breadth. Very clear. So let's see. For this side right here, the area, and if it happens that you have more than one area, you just sum them up to get the total area, right? So basically this one here is not just area, it's the sum area, right? So let me just put this here. The total area, right? Find the total area, not just the area. The total area under the cycle, not just any area. Okay, so let's correct that. Total area. So if it happens to be a complex something, just sum all the areas under it. Right? So let's see. This one right here, the area, let's forget, will be length, which we have it to be, here was 2, right? 2. That will be 2 times E, right? And the area right here, this one, will give us length, which is 4 minus 2, right? Because this 4 minus this 2, that gives us a 2, right? And then times the width. The width is the negative E that we're having, right? So basically, our total area under the curve, the cycle that we've identified, right? That will be, this is 2E, right? So we have 2E, right? And then we're adding the other one, right? This is 2 minus E, so that gives us minus 2E, right? So this is our total area. And then we know our period to be equal to what, which we wrote earlier, 4 seconds, right? So basically, our average value, right? So it depends. If it's a current, you put the unit. If it's a voltage, you put the unit there. So if this were to be a voltage waveform, right, just purple, that's the yellow is not there. We have our average we have our average voltage to be the 4 that we found, right? So the easiest thing could be any quantity, either voltage or current. So right, so it could be any of them. So that will be end up being 0, right? 0, yeah, whatever it is, whether voltage or current. So we end up getting if you want to find the average, the 0 on the 4, right? Because it's voltage, that will end up being as 0 volt. If it to be current, the same thing. These are the unit change, 0 and 4, and that gives us what, 0 amperes, right? So that's how we find the average values, whether voltage or current. Right?